Hey, good morning all. Um, I'd like to just walk through this paper with you. Now, when we looked at the Faraday's lab, the thing that you should have brought home with you, the most important part of that entire lab, is that to make electricity, you take some kind of magnet and you spin it, some type of coil, and you spin it inside of a magnet. Okay, so if this is a magnet with a north and a south, and if you can spin this around, you can't see it really good. I'm going to use a pen. That's better. So this is the copper windings, and this is the magnet. And so you have to imagine this is a cutaway. So here's a from the north. Bring it in a bit so you can see that. So if I can cause this wire to spin inside of this magnet, then I will get electricity being made. Now that is the most important part of the Faraday's law that you should take home. So when we look at this diagram here, almost, not quite, but almost all electricity that is generated for our use is the same in this box here. I need to make more. So this is going to be a funny looking box, but pretty much all electricity is made and distributed the same inside this big box here. What changes is this part here. So what we have here is this is the turbine. Now, turbine is just a fancy word for propeller blades. So this is the turbine. Number 2 is the turbine. And the turbine is hooked by a drive shaft. So this is the drive shaft. To the generator. So number 3 is the generator. And the generator is just this part here. That's the generator. That's the part where we have a magnet, a permanent magnet, and inside we have these coils that spin. And it's that spinning that causes electrons to flow. So what we come out here, we have electrons flowing, or power. So electricity is coming out here. And this is called a transformer. Okay? Now, what a transformer does is it increases the voltage of the electricity many times, so that typically the transformer will increase the voltage to around, I think it's 50,000 volts. We can check that, but it increases it. And the reason why they want to do that is because when the electricity comes out here and goes to the high tension wires, where the the electricity has to travel over great distances, sometimes hundreds of kilometers. They find that if they have, say the electricity was made at 500 volts, by the time the 500 volts got the hundreds of miles, it would have lost so much energy that hardly any electricity would be getting to the end user, getting to your home. So what they do, they found that if they increase this to a high number, that you don't have as much loss over the miles. So that's what's happening here, is that this is upgrading it or stepping up the voltage so that it can travel great distances to our end users with very low loss. So this is transformers to avoid loss of energy. Now we'll look at other. Now it doesn't come into our house at 50,000 volts. Typically it comes in to our house at 120 volts. There's two lines, a 120 volt plus a 120 volt. Okay, so two of them come in like that. So this here would be the transmission lines. Transmission lines. Okay? Now, so as I said, that everything inside this box, I'm going to just do a yellow box. So, with the exception of solar power, all other forms of electricity share this part in common. They all have some kind of turbine to spin a shaft. They all are hooked to a generator which makes electricity, and they all go to a transformer to step it up. They all go through transmission lines, and it's all ultimately delivered to home and businesses. Okay, so this is all the same. Now, if you look at the title of this page, what you'll see is this word here, thermal. And thermal really means heat powered. Okay? Now, let's look. So how this works is that some heat is applied by, there's a couple of different options, but basically we have to have a heat source, and the heat source heats up the water. So this is heat, this is liquid water, and it heats it to high pressure steam. So this is steam, that is high pressure, and this steam, because it's in an enclosed container, that's how we can make the high pressure, and it is piped through here, high pressure. This is what causes the turbines to spin. Okay, so this is what causes the turbines to spin. Now, as you could probably guess, we've got to get rid of the steam, but we don't want to get rid of it totally. So what happens is that we take this steam, and this goes down into this area here. This is called a cooling tower. Okay, and what happens is this steam turns into water again, and it is replaced back here, because if we just kept heating water and the steam went up, eventually all the steam would boil away and we'd have no water here. So if you, these towers are very large, and it looks like smoke is coming out of it, but it's not smoke. That's actually just water vapor, big white clouds come out. So that is, some water vapor is lost, but a lot of it is recovered and added back to the water here. So this is thermal. Now, thermal power generation was the first real power generation that we've used historically. And in order to get heat, generally speaking, you have to burn something. And so traditionally what was burned was either coal or oil. Now, right now, there should be a little flag in the back of your head going up and saying, oh, wait a minute, Mr. Hayden, isn't that, aren't those two examples of fossil fuels? And you're right. Because of this, thermal, here's random notes to myself, thermal energy, at least in this form, produces a lot of pollution. And this is one of the contributors to global warming. And climate change. There's another problem with this. That is that coal and oil and all other fossil fuels are in limited supply. That means that eventually they're going to run out. And if that runs out, then human civilization as we know it would cease to exist, at least the civilization part of it. Okay? So you should go through this again on your own and walk through the steps of what happens here, what's happening here, what's happening here, throughout, and what's happening here. Okay? Now, you'll probably see other videos on this, but that's it for today. Okay? Thank you. Bye now.